Okay, for the third pass, we're going to look at some tolerances, which items could be 3 decimal places. Um, from a practical standpoint, putting all of these at 3 decimal places is fine. Um, if we're dealing with stock sizes, 12 millimeters, standard stock is going to be a 1/2 inch. If it comes in as bar stock, it's going to probably be um, zero point 0.5 to 0.505. If it's plate, it'll probably be around 515. Um, width-wise, said we could probably put it in overall, but well, let's see, I missed a radius there. So the full radius, that would put it up to about 0.7, actually about 7/8. And little by little, we're going to go through this process. All right, so we start thinking about the mechanics. Let's go back through. This is where the dynamic portion of the movement comes in. That this is one of these is going to have to spin. So whether it spins in the base and then is pressed into the disc, or the disc spins on the end, that's going to drive which way those tolerances are going to go. So if this is a press fit, and then this is a clearance fit, then that's going to be a determination. So press fit, clearance fit, and then clearance, but then pressed into the end of the slider, and then it has to be able to move, and then press fit into the supports. So that gives you some indication. So one of the first that we'll do is go into the document units and switch from 2 places to 3 decimal places. And where we can get away with it, then I will go back and individually decide, well, that's going to start off as a 2.5-inch piece of material, so that'll probably round down to 236. So overalls are not going to be very critical. But then positions, and especially between, which now we're catching dimensions that I missed. We can go back through. I got a little too close to that. Still too close, so let's just escape out of it. Smart dimension. Probably should have put a center line through the whole thing. And then if we use that, that's probably not a best practice, but we can use it for reference, and we'll try to minimize the amount of lines crossing. So position-wise, that would be pretty close. That actually might need to be closer depending on which way the support goes. And so the depth should be okay, but the 197, I would maybe look at going with a bilateral dimension so that it becomes a press fit of minus 1/2 thou. All right, so that's going to go from a nominal just a line to line to having a general press. So if I go to 4 decimal places, okay, that got the sizing, and for a 5 millimeter hole, that's okay. So again, I don't want to go in and beat this up too much, but we do need to just be aware of how these tolerances are applied, and then the more that you use them and think about their functionality, you'll start to tie these concepts together. So 4 decimal places with a 4 decimal place tolerance. Make sure that, no, 5 thousandths, oof, that's going to be a heavy press fit. Let's go 1/2 thou. All right, so each of these is going to have something. So on the clearance side, maybe we will go back to, so basic dimension is going to be controlled by a geometric tolerance somewhere. Bilateral was what I was doing, +0 -nothing. A limit distance would change it to a high number, low number, And then symmetric is basically what's happening with the plus minuses. And then min, max, and fit tolerances if we want to go to that next level. I think for our purposes, bilateral will suffice. And actually, I picked the wrong 394 there, so let's go back to none. And was thinking about that 394. And since I did not put a second view on this, if I make this side a press fit, so our tolerance would be that if this grew by half a thousandth, so 5/10 of a thousandth, and was pressed into the base, which was minus, we could have a total interference of 1/1000th of an inch, right? Which is still a relatively, you're not just gonna put it in by hand. You need a mechanical device to force those fits together. All right, so annotation, nope, drawing, projected view. We'll bring this one over. We're okay there. Need a tolerance. So the one that's going to be the clearance now is effectively opposite. So 394 with a minus. 5/1000ths. Switch it over to 4 decimal places. All right, so this would go into the drive wheel. The pins, those are going to be, like I said, probably a stock. So we'll want to put the tolerances on the holes, not necessarily the pin or the purchase part. So this one we want it a little bit bigger because we're going to start dealing with positional tolerances, which is more geometric. But you know, we're working in that direction. So I would say this one is probably going to be on the order of plus 1/1000th. And then when we were in the base, I was going to press those in, and the issue is any misalignment that we have to account for with that pin going into this. It's going to just make it that much harder, and we have to determine how many parts we're willing to destroy, how many pins we're willing to bend to have that fit. And at some point, we're going to have to make a decision. Do I want to make this a counterbore hole that has a relief and just put a threaded fastener through there and do away with the pins altogether? Cost-wise, it's going to cost a little bit more in additional parts, which is affecting the bottom line, but we're going to have something that's maybe easier to assemble than dealing with those press dowel pins into the part. So 394. Let's see if we come over here. We're going to be able to pick it up. All right. So the tolerance type is bilateral, and now I got to remember what I told it on the pin. So we can go to a positive of 5/1000ths, and we'll switch the tolerance over to 4/1000ths, or four decimal places. All right, so we've got that 10 millimeter 0.03 or 0.3937 with a 1/2,000th plus, and we jump back over to the pin. We have a minus 1/2,000th, and then a press on this side, a clearance on that side. If we get too much clearance, then it's going to have a tendency to wobble, and as we go through that epicycle of movement, and this is loading, unloading, it's going to have a little bit more wobble, a little bit more to deal with. All right, so press fit on the 315 would be, let's go to bilateral, would be a minus 5,000 or 5/10ths, and we'll switch that to a 4 decimal place. And the other size clearances, that should do okay. All All right, and then on this side, the 197 is going to be a clearance fit, so we want it to be a little bit smaller. And the hole to be a little bit bigger. All right, and every time I do this, I got to think I'm increasing the cost of this part, but is it going to increase the functionality and the life cycle to a better specification? All right, so that pin has the side of the arm, so bigger number to the smaller number. Okay, so the 315, yep, that one's a little bit larger, the other one's a little bit smaller, so we'd have a maximum of 1,000th of interference and then a maximum of 1,000. Now this would technically qualify as a transitional fit rather than a running fit. And I know I'm throwing out a lot of terminology, but this is the thought process of applying these tolerances. So because I could still have a line to line, that would basically make this a not necessarily a press fit, but certainly not a clearance, then I would want to revisit that tolerance at some point when we actually get to the arm. All right, so same step. We make both of these a plus half thou. Switch it over to 4 decimal places, and that takes care of each of those with the 2 times. The rod, again, a purchased part, so I should probably refer back to what I did with the pin. I just left it stock, so we'll have to revisit that one as well. And then this one for the clearance, probably the same thing. Bilateral, this would need to be a positive, and we'll just say a positive 1,000th of an inch. And tab will update it. So I have to think about what I want for those for that slider to function and move back and forth. All right, so the bilateral minus 0.5 and a press fit for the pin so that it doesn't wobble around in there while the arm is moving back and forth. All right, so let's see, on the brake, we'll get back to that arm, and still haven't quite figured out the what happened to the center mark. I pushed a few more buttons, but it's still not quite allowing for the center marks. But once I applied the dimension and went back to the brake view, pick the view, and then place brake, then it shortens it up a little bit. And I'm not sure what the brake sketch blocks does. That's one I'm going to have to look up in the help. However, it did keep my dimensions. And so in this case, the overall I'm not real concerned about, so maybe that goes back to a 2 decimal place. And trying to use these little pop-ups a bit more, I'm not, can't say that they're always my first choice. So that gives us maybe the width as well. Okay. And that can pretty much take us through our second pass, or third pass, excuse me.